about complex numbers. So complex numbers follow the whole radical, rational, that kind of stuff, because complex numbers are actually what happens when I take the square root of a negative number. Okay, so what happens when I take the square root of a negative number? It doesn't exist. Mathematicians discovered a long time ago that they needed it to exist. So they created a new number system around the square root of negative 1. So the complex number system, it contains all real numbers. This is important to realize, the complex number system. So you remember, for example, integers contain all whole numbers. Real numbers contain all integers, rational numbers, and non-irrational numbers. So complex number system contains everything except, including imaginary numbers. That's what they're called. They're complex numbers. So they're numbers that that don't exist in the real number system. So addition, subtraction, multiplication, and division all obey the same rules. So you don't need to worry about that. The exponent laws hold for integer exponents, but not necessarily for fractional ones. So if you have a rational exponent, it may not be the same. So the complex number is, so this is where the number comes from, the idea that I squared, sorry, I forgot that pen doesn't work. I squared equals negative 1. Now, all complex numbers can be written in this form, okay? A real number plus a number times I. All right, so this is considered a number. I know it has an addition sign in it, but it's considered a number. Move this over, sorry, I should have done that. Okay. So, and then this rule down here, it says A plus BI equals C plus BI only if and only if A is the same as C and B is the same as C. So that's kind of a given. All right, so that's complex numbers. So how do we deal with complex numbers? Okay, I'm going to come back to the I-26 in a minute. I actually want to do this one first. So the square root of negative 81. So we think about it without the negative first. So what's the square root of 81? It's 9. Okay, and since it has a negative, the square root of negative 1 is I. The answer is 9i. That's my answer for the square root of negative 1. Now what happens if I have I to a huge exponent? So this is where these rules come in down here. And you're going to want to memorize these or at least know how to use them. Okay, I to the first power is 1. I squared is negative 1 because the square root of negative 1 is I. Okay, I to the third is I squared times I, which is negative 1 times I, which is negative 1. So there's only 4 possibilities, well, I guess 5. Okay, I to the fourth is I squared times I squared, negative 1 times negative 1, positive 1. I to the fifth is I to the fourth times I, 1 times I is I. So then it starts all over again. So what we need to do, if we have this I-26, we actually need to take and divide it by 4. So if I divide 26 by 4, because really I have 4 possibilities here, 5 is the same as 1. Okay? And you have to do this a long way, calculators won't work. So this goes in here 6 times, right? And I have 24. Minus that, I have 2. This is what I care about. I don't care about any of the rest of it. Okay? I don't care that it goes in 6 times. What I care about is my remainder. So my remainder is what's going to tell me which one of these it falls under. So this is actually the same thing as I squared. And I squared is negative 1. So I to the negative 26 is negative 1. Okay, this works on the idea of remainders and that they're the same. And if you were to work it out the long way, I squared times I squared times I squared, you would end up with, if you were to divide it into 13 I squared, you would still end up with negative 1. So. All right, so this is your practice problem, which find I to the 54. Okay, remember, divide by 4, look for remainders. All right, so this is the practice solution. All right, so now how do we simplify problems like this? This is simply like we're doing normal FOIL, okay? First, inside, outside, last. All right, let's see if I can do this without making this mistake on the last. So I have 2 times 5 minus I times 5 plus 2 times 2i minus I times 5. Okay, and now I'm going to simplify. 2 times 5 is 10. This is minus 5i plus 4i. Okay, I times I is I squared, which is negative 1. So plus 2, because negative 1 times negative 2 is positive 2. Now I'm going to simplify one more time. 10 minus I. Oops. Try this again. Okay. 10 and 2 is 12. 12 minus 10. Okay. Look at this form. This is that A plus BI. All irrational numbers or all imaginary numbers can be written in this form. Sometimes A is 0. But so the A is 12, the B is negative 1. Okay, practice problem. Okay, I'm just going to come up with that there. There's your solution. This was actually one that ended up without an I plus sample. All right, now simplifying. With denominator. So the idea that I is actually a radical number. You don't want I in the denominator, so we will have to rationalize if it doesn't work out nicely. So I have 1 over 2 minus I times 2 plus I. So I will simplify. First, inside, outside, last. Okay, so I have 2 minus 2I plus 2I minus I squared. Okay. These go away. So then I have 1 over 2. Now I squared is negative 1, so it becomes minus a negative 1, which is plus 1. My answer is 1/3. So there's a lot of problems that involve complex numbers that actually end up with answers that do not have complex numbers still in. Okay. So there's this one. Okay, again, it wants it just in a regular form, A plus BI, that's the standard formula. So it's basically rationalizing the denominator and going that route. Okay, example 4. So solving equations with the quadratic function that do not have a real number solution. And this is where we'll actually use complex numbers. So I have 5 plus 2x plus 1 equals 0. And I want to solve these. These will have complex solutions, not real solutions. So it's the quadratic formula is negative b plus or minus the square root of b squared minus 4ac over 2a. Okay? So I have negative 2 plus or minus the square root of 4 minus 4 times 5 times 1 all over 2 times 4. So I have 2 plus or minus the square root of 4 minus 20, which is negative 16, over 10. So now I'm going to continue. I can actually get a solution here. 2 plus or minus 4i over 10. And you can leave it like that. You can simplify actually a little bit further in 1 plus 2i over 5. Alright. Moving on, I think that's a practice problem here. I did. So this had 4 practice problems, but keep in mind, a few of the lessons before, we didn't have any practice problems, and we only had 1 or 2. So use your quadratic formula to come up with the solution. And there's your answer. They're complex solutions. And that's it. See you tomorrow.